Good evening. Astronomy lesson 3.2. Mustache. Okay, anyways, welcome to Astronomy lesson 3.2, coordinate systems. First thing we need to know is our celestial meridian. This is the circle that goes through the north and south cardinal points and through our zenith. So again, the zenith is a point that is directly above our head. So this is what cuts our celestial sphere in half. How fun is that? All right, next. Some things you should know about the celestial meridian. First, the objects on the meridian are what we call in transit. Astronomical noon is when the sun is on the meridian, and astronomical midnight is when it is on the meridian but below the horizon. Now, just because it is directly overhead, just because it's astronomical noon does not mean that the sun is directly overhead. It depends on the season in order for that to occur, and we'll talk more about that when we talk about annual motion. All right, so moving on. We can measure how high above the horizon a star or planet is located by the distance that it makes to our zenith. So if you picture this part right here as the ground, right? So this is our flat ground, this is the horizon. Anything below here we can't see, anything above we should be able to see. This is the ecliptic. This is the path the sun seems to travel through the sky on any particular point of the year. So this looks more like a winter solstice situation. This is probably more what we're seeing now if you're turning in on February 7th. If you are in the earlier astronomy classes, then this would be later. We have our zenith directly above our head. Here's our little stick figure right here. There's an incline of 23.5 degrees because of the Earth's tilts. Then here's our celestial equator. It cuts the sky there. Notice that there's 23.5 degrees tilt, again, the Earth. Here is our meridian going from north to south, cutting that sphere in half through our zenith. And then again, the celestial equator there. This shows the rotation, so that's fun. Alright, so we can find points in between there. So if this is 90, whoa, that was weird. I hit a button. So this is 90. And then somewhere like halfway in between, that would be about 45 degrees. So you could say Polaris is at 45 degrees north of us, and you'd be mostly correct. And that would just tell you where to look in the sky. So these are some useful terms so that we can see, and here's another picture. Kind of shows you the difference here. See, altitude. This is our horizon or azimuth. You will hear more about alt-azimuth telescopes when we talk about telescopes, but ideally altitude is height, azimuth is our north, south, east, west. Mostly we're looking at things in right ascension now, which is in hours and minutes. Alright, so let's talk about Polaris. I mentioned Polaris being at the North Celestial Pole in the last lesson. It's just slightly off about 1 degree, and that is our North Star. So if we can find that, we can find our north. It's very good if you are trying to navigate, but it's also kind of interesting if it is there, because it also makes your location on Earth, your latitude, the height that it's in the sky. So we take someplace like equator. Your altitude is 0 degrees because you're on the equator. The North Star would be at the 0 degree line, so right at the horizon. If you were somewhere like the North Pole at 90 degrees, then the North Star would be directly overhead at your zenith at 90 degrees. And if you were somewhere like Grosse Pointe Your latitude is around 42 degrees, and that North Star is going to be at around 42 degrees in the sky. Fun things. Alright, so we'll close up there, and I will continue the next lesson later. Thank you very much. I'll talk to you later. Goodbye. Smiley face.